Hello everyone, I'm Ariyadi Wijaya from the Department of Mathematics Education, Universitas Negeri Yogyakarta. In this occasion, I would like to present my work on emerging modeling from playing games to learning mathematics. So the main idea of my presentation is how we can use games as a tool or as a media to learn mathematics. I would like to start my presentation by revisiting the concept of mathematical modeling proposed by Werner Bloom. Bloom mentioned that as a whole process of performing mathematical modeling, there are 4 steps. The first step is understanding the task. The second step is searching mathematics. The third step is using mathematics, and the last step is explaining result. In line with the idea of these 4 steps of modeling proposed by Bloom, I and my colleagues a decade ago, we conducted a research on identifying Indonesian students' difficulties in solving real-world problems. We identified 4 types of errors, that is comprehension error, which correspond to the error in comprehending the task or understanding the task. The second error is transformation error, which is the error in selecting required mathematics concept. The third error is mathematical processing error, that is error in performing mathematical procedure. And the last error is encoding error. That is error in interpreting mathematical results in terms of the contextual problems. Among the 4 types of errors, we found that transformation error was the majority. It means that many Indonesian students were struggling with identifying relevant mathematics concepts required to solve a contextual problem or real-world problem. Therefore, I would like to highlight that the 4 steps are important, but now I would like to highlight on the second steps of mathematical modeling, that is searching mathematics. Because, as I said before, transformation error was the majority. Searching mathematics means that the students are able to identify, to find the mathematics concept relevant to solve the problems. In relation to the searching mathematics, I would like to connect it to the idea of emergent modeling proposed by Grafo-Meyer. Grafo-Meyer mentioned that if students work with real-world problems, let's say, there are 4 levels of modeling. The first level is situational, which means that students they are really doing in terms of the context, in situation or the context of the problems. The second level is referential level. In this level, students are still thinking about the context, but they do not really play directly in the context. Instead, they use a tool to refer to the situation or the context of the problem. So, close to the context, but not directly performing the context or the situation. That is the referential level. The third level is general. In the general level, students already, let's say, eliminate the context of the problems. They already think about the mathematics. But it's not at the highest level yet, because the highest level of the modeling is the formal level, which is the abstract concept of mathematics. To support students to move from situational level to formal level, I use a game-based learning, which means that we use games to support the students' learning of mathematics. In this presentation, I will provide 3 examples. 2 examples are aimed to illustrate how games can be used to build students' conceptual understanding. And 1 example is aimed to illustrate how game-based learning can be used to develop students' modeling competence. Let's start from the first example. This example is from elementary school level, that is grade 2 or about 8 years old. I and my colleague use design research by Gravemeyer and Kopp as the design principle for using games as the media to learn mathematics. That's why we have 3 components. The first one is the learning line of students. The second component is the instructional activities. And the last aspect is the basic concept of linear measurement. This is as the goal. In terms of the activities, we had 3 kind of activities. The first one is experience-based activities. The second one is bridging activities, and the last activities is formal measurement activities. For the experience-based activities, we use games, traditional games. The first one is gundu or marbles. So, marble. The idea of the game is that every player has to throw their marble as close as possible to a circle on the ground. The player whose marble is the closest to the circle can, let's say, can eliminate the other marbles. So, the activities of the game, which is close to the concept of mathematics, is when the players have to measure the distance of their marbles to the circle. So that's the idea of the mathematics in the games. And then after playing the games, we provide a bridging activities, that is making or using string of bits and making our own ruler. So from the games, gradually we develop a more general tool, that is a string of bits and students' own ruler. And then at the end, they will arrive at the final level of measurement, that is by using a normal ruler. Here's an example of the idea how an activities move from situational level to referential level, general level, and formal level. In the games, I mentioned before about the marbles. In the situational level, students were really playing the games. And then when they measure, at the beginning, when they measure the distance of their marbles to the circle, most of students use their handspan. But in order to bring the activities into the learning objective, that is the linear measurement, we provide a kind of conflict, that is a fairness conflict. We ask students, is it fair if we measure the distance by using your handspans? Let's see your handspans. Are the size similar or different? So when the student start to realize that the handspan or the measure of their hands are different, we stimulate them to think about another tool which is fair to measure the distance. And then, of course, by having some discussion at the end, we arrive at the marble as the tool to measure the distance. So the fairness conflict can bring from using body parts to use a more stable tool to measure. This is situational level. That is, students are really playing the games. And then when we move to the referential levels, we still think about the games, but we no longer play the games. In this activity, we introduce the string of bits as kind of substitution to the marbles. And then, in the next step, general level, gradually we plan to introduce the ruler, but we use paper stripe as the stepping stone. So we develop a paper stripe from the string of bits. And then lastly, at the formal level, we put numbers on the paper stripe, and then at the end it becomes a ruler. That is the standard measurement tool. But from this activity, actually, a ruler is not the only one. It's not the only concept built from playing the games. But there are other concepts which can be derived from the activities of the games. The first concept is identical unit, because as I said before, that different hand spans might arrive at a non-fair game. So we need to use a marble because the size of the marbles are equal. It means that to have an accurate measurement, we need to use identical unit. The second concept derived from the activity is unit iteration. When we put several marbles, or we make the string of bits, or we use paper stripe, it means that we iterate the unit one by one to do the measurement. So this example shows that games can be used to develop a linear measurement. Another example is from a junior high school level. It's about 14 years old. Again, we use a game-based learning, but in the studies, we use the game to introduce the concept of probability. We use a quite famous game, that is snakes and ladder games. We also use the design research by Gravimer and Kops. We have three components: learning objective, learning activities, and students learning, conjecture of students learning. The first activities is about deciding a fair rule to determine the first player of the games. So, who will throw the die first? We ask students to decide what kind of strategy to fairly determine the first player. After having some discussion, at the end, student comes to the idea of flipping a coin, or rock, paper, scissors, or rolling a die. When they are asked about why you think that strategy will give you a fair rule to determine the first player, they answer that, yeah, because we do not know what will come when we throw a die, or we toss a coin, or we do a paper, scissors, and rock. It means that not knowing what will come, it's the idea of random event. So the games can be used to introduce the concept of probability. And gradually, when the students use the snake and ladder games, they throw the die, and then we ask them to record. Then we introduce the sample points and the sample space concept. And then at the end, we introduce the empirical probability concept. Our study shows that it's kind of two-dimensional shifting from games to mathematics. First, in terms of modeling, that is, from the games situational level to discussing only the tool as referential level to make a table as the general level, and lastly about the concept of probability, both empirical and theoretical probability, as the formal level. So, emergent modeling. The second one is the concept development. How we can use the games to introduce several sequence of concept from random event, sample points, sample space, empirical probability, and lastly theoretical probability. So it shows that the game is promising. It has a big potential to introduce mathematics concept. The last example is about the use of games to develop students' modeling competence. That is, games and mathematical literacy. The game here is a role-playing games, and it's played by senior high school level students. So it's about 17 years old. And in this occasion, in this situation, students already learn the required concept, because the main idea is not to build conceptual understanding, but the main idea is whether a student can apply the concept they have learned before, whether they can recall a relevant concept to solve real-world problems. The idea is the student, they are asked to play a role-playing game as an archaeologist. An archaeologist found a broken plate. This is the shape of broken plate. And the goal is to reconstruct the broken plate into its original size and form. And these are the result of student work when they were doing role-playing games. They really cut. They say that, okay, we make a copy of the broken plate onto the paper, and then they cut it, we fold it, and then they cut it, and then we unfold it to get the result, to get the plate. This is the first strategy, fold and cut. The second strategy is cut. They cut the plate, and then they duplicate it, they make a copy of it, and then they tessellate. They construct the plate and its duplicates to form a circle. At the end, they claim that, okay, this is the real size and form of the broken plate. Okay, another one is they cut the plate, they rotate it to get a circle here. And then another one is, it's quite advanced. They half cut, they cut the plate, they fold it to have this line. They have this line, and then they fold again to have this line, and then it becomes the center of the circle. And then they can construct the circle. This example are when the students were working with GeoGebra. The student directly use features of GeoGebra, that is construct a circle through 3 points. So they put 3 points on the plate, and then automatically they get a circle. Another student use a semicircle, also a feature of GeoGebra. And then they use a symmetrical line, reflect the semicircle to form a circle. So the role playings can stimulate students to think of several strategies, because they were really engaged, they were really enthusiastic to do the activities. But once again, the idea is to bring the mathematics. So from students' activities, we need to highlight the mathematical concept. Like this one. When the student cut and fold the paper, and then we trigger them, we stimulate them by posing question. Can we do it without cutting the broken plate? So the students were thinking about the strategies to construct these 2 lines without cutting and folding the papers. And then At the end, they get the idea of arc and segment here. Chord, they make a chord here, and they construct the apotheme, and then they can construct the circle. So this question can trigger students to move from maybe just hands-on activities to minds-on activities. They become aware of the mathematics embedded in their hands-on activities. Similarly, when the students are using the feature of GeoGebra, we also ask them, what should we do if we use compass instead of GeoGebra? At the end, they realize that these 3 points on the circles mean a triangle. So, by using compass, they can construct a circumscribed circle of the triangle. And then at the end, they have the circle. So, the activities, the role-playing games, at the beginning really trigger students to do mathematical, to do exploration, any exploration. Perhaps they did not really realize about the mathematics, but they think about the situation of archaeologists. But by giving a scaffolding and proper questioning, at the end, the student aware of the mathematics they were using during the activities. So, now it's close to the end of my presentation. I would like to highlight several key points to consider when we use game-based learning. The first one is familiarity with games. It's important to use a game which are already familiar for the students because it can improve students' engagement. The second one is providing conflict in the game is important. Like my first example about is it fair to measure by using different hand spans, or is it fair to determine the first player by tossing a die? That kind of conflict, that kind of question can develop, can trigger a student to think about the mathematics, to think about another strategy. The third key point is we need to consider that a game is not a standalone aspect in the game-based learning because teacher scaffoldings also plays an important role. Like my previous question, when I use what if question, what should we do? We do not use GeoGebra. What should we do if we only have a compass? Can we do it without folding the paper? So that kind of questioning is an important way to improve students' awareness of the mathematics and at the end to find the concept of the mathematics. Okay, so that's the key of my presentation. It's about how we can use game for learning mathematics. That is 2 directions to build mathematics concept, or the second one is to develop modeling competence. Thank you very much.